AP Stat babies, we are getting ready to do some basic probability examples. Doing examples is the best way to learn how to do this. So once you get to the point of you're so tired of probability examples that your head might explode, that's when you know you've got to do 10 more. Okay, so example 1. We have an urn, how exciting, of 10 marbles. 4 are red, 3 are blue, 2 are green, and 1 is purple. I want you to draw 1 marble and tell me what the following probabilities are. Notice the notation here, P of red. That means the probability of a red marble. Well, 4 out of the 10 marbles are red, so you're done. Don't reduce it, just leave it. Okay, the probability, I don't know why I forgot my P here, the probability that we do not have a green one, this is going to speak well to an illustration of one of our rules of probability. Because if I'm dealing in terms of just green here, the probability, since there are green marbles, the probability of a marble being green plus the probability of it not being green is equal to 1. That means if I want this probability, the probability it is not green is equal to 1 minus the probability it is green. And since 2 out of the 10 marbles are green, 1 minus 2 over 10 is 8 over 10. Could you just as easily have counted the other marbles? Yes, but then you would have missed out on seeing one of the probability rules in action. You're welcome. Okay, next example, probability that it's green or blue. All right, well, we've got 3 blue and we've got 2 green, so that would be 5 out of 10. Why, Miss Griggs? Because 3 out of 10 are blue or 2 out of 10 are green. So if it's or, that means I add. So there you go. It's magical. The probability it's striped. Well, kids, there aren't any striped marbles. So that is just 0. 0 out of 10 or 0. That's what that looks like. Okay, next problem. Now we're going to draw 2 marbles and it's going to be with replacement. That means we're going to pull a marble out and then we're going to put it back in and draw the second one. All right, so it is important that you understand that this does in fact matter on how you do the problem. So if I want the probability that both of the marbles I pull out are blue, well, the probability of one of them being blue is 3 over 10. Okay? And then I put it back, and the probability of the next one being blue is also 3 out of 10. And the first one's blue, and the second one is blue. This is a multiplication situation, so 9 out of 100. Red, then green. Well, the probability that the marble is red is 4 out of 10, and then the probability, I'm going to put that marble back in, so then the probability of getting a green one is 2 out of 10. So the probability here is 8 over 100. Magical. All right, 2 marbles without replacement. This is so important. It's going to change things. Not how we do it, but the result of what we get. Okay, now I want the same probability I found up here. Now the probability that both of the marbles I pull out are blue, well, the probability of the first one being blue is still the same, 3 out of 10. But now I'm leaving that marble out. So now I'm 1 less blue marble and 1 less total marbles. So don't say anything about me losing my marbles. I know that's what you're thinking. So the first one is blue, and keeping it out, the second one is also blue. 2 out of 9. 1 less blue, 1 less total. So now my probability is 6 out of 90. Same thing's going to happen with this red and green here, except for the fact that this time the colors are different. So the probability I get a red one out of 10 is 4 out of 10. And then I leave it out, so I'm 1 less marble, but I've still got 2 green marbles. So now this one is 2 out of 9 because there are still 2 green marbles. There's just 2 out of 9 instead of 2 out of 10 now. So this is going to be 8 out of 90. Isn't that exciting, kids? I knew you would be excited. So this example illustrates just some basic probability for us. Shouldn't be too tragic.